All right, first we're gonna start off with building the circuit. So we have both the 1 UF capacitor and the 0.1 UF capacitor, the BJT, and the 5 resistors we're gonna use. First we're gonna start off with the BJT. All right, we're gonna use connected to the base of the BJT. We have the 1 UF, so we're gonna add that. All right, also connected to the base, we have the 56K resistor and the 4.7K resistor. So we're gonna get those, the 56K. Connected to the base. Which is also connected to 15 volts. We're gonna have it on this side. Just connect that there. And then the 4.7K is gonna be connected from the ground to the base. All right. All right, next is the emitter. We just have the 470 ohm resistor connected straight to the ground. So the emitter's on this side. We're gonna just have this go right to the ground. Okay. And then we're gonna do the collector next. So from the collector, it's gonna be the 6.8K, which is connected to the 56K, which is also connected to the 15 volts. So we're gonna grab the 6.8K ohm from the collector. We're gonna connect it straight right here to the 56K. And then from both of those, I'm gonna grab a wire and connect that straight to power to connect the 15 volts later. And then also connected to the collector, we have the 0.1 UF capacitor, which is connected to the R load 5.6K. So we're gonna grab the 0.1, go from the collector to here. Yeah, I can't get it. All right, that one's connected to there. And then from the capacitor, we're gonna grab the R load, which is the last resistor, the 5.6K. And this is gonna be connected to the capacitor, straight to ground. Yeah. And then now that we have all those, we gotta start connecting the wires from the MyDAC. All right. So we have the first one, the 15 volts. Gonna go straight to the power. All right. And then the next one, so we're not gonna use the negative 15 volts. We're gonna put that off to the side. The next one is just the ground. So we're gonna ground that on the circuit. Then we have what's next? The 0, the output. Oh yeah. So the output or the input, whatever, is going to be connected to the VN. So right here, grab our 0, connect it there. Then we're not going to use the 1. Put that also to the side. All right, then the next one is the ground. So we're going to ground that again. Then we have the other output for the 0 plus. We're going to connect that right here for the V out. So where the 0.1 capacitor and the 5.6 R load are. So that's going to be right here in this lane, this row. We're going to connect the 0 minus to ground. And the last 2 we're not going to use. We're going to put those to the side as well. All right, so now I'm going to open the digital multimeter to measure the DC voltage across the 6.8K. Yeah. Right there. So we're going to open that up. So I'm going to open the digital multimeter, the function generator for the next step, and then the oscilloscope for next step as well. But right now we only need the function generator, not the function generator, the digital multimeter. All right, and then so for the first step, we're going to find the DC voltage across the 6.8K resistor. So now we have to plug these in. All right, and then the next one. All right. All right, so we're measuring this one right here, the 6.8K. Let's make sure it's on DC voltage. Got my probes. All right, and I'm gonna press run. And I'm gonna measure, and it's getting 6.8 volts. All right, and that is gonna be for the first part. So we have 6.8 volts for the DC. Yeah. All right, for the first part, so that's what we just measured, the DC voltage across the 6.8K. And we got 6.8 volts. All right, the next part is the DC current across the same resistor. So go back to the digital multimeter, and this time we're going to change it to DC current, and we're going to switch it to that one. All right, set this back up right here. All right. Switching that one. All right, I'm going to stop it and run it again real quick just to make sure no problems. Running it. All right, and then so we're going to measure the same resistor, but this time for the DC current. And it looks like it's getting 0.002 amps. Let me measure it again. Yeah, so 0.002 amps, which is going to be 2 milliamps for that one. All right, and then for the next part, we are going to set up the function generator to a 5 kilohertz sine wave, and then we're going to run it. So we can unplug the probes and close out the digital multimeter. All right. X out the digital multimeter, and then we have the function generator and oscilloscope open. All right, so we're gonna set this to a 5 kilohertz, and it didn't say the amplitude, so VPP, so we're just gonna keep it at 1 VPP. And then we're gonna run this, make sure this one right here is enabled, and then we're gonna run it as well. All right, and so it looks like that. So we're gonna change them up a little bit. So let's try to make that 5. Make that 5. All right, so we're gonna have that, and then let's just run it once. And then so our input, our VN, is 5.958 for that one, and then 5.636. So that's just the normal one. But for this one, it says remove the load resistor R load since you'll begin with an unloaded voltage. And so the R load is going to be the 5.6K resistor. So we're going to go back to our circuit, and the 5.6K one we're going to remove. And that one is this one right here. So we're going to remove this for the unloaded and just hold it to the side. All right, and we're going to go back and we're going to rerun it. So run. All right, and so now our VN is going to be 13.147 volts. So let's type that in right here. 13.1, what was it? 147. And then our V out is going to be 12.452 volts. 12.452 volts. All right. And so on the next step, what is it? Yeah. So the next step, we're gonna add the load resistor back, and then we're gonna find the same measurements. So get my 5.6K resistor back, 5.6K, and we're gonna put it back where it was. Oh, did I stop running? Yeah. All right. Where was 5.6? 5.6 was connected to the capacitor and the ground. So get that back to the capacitor and connect it back to the ground. All right. Perfect. then go back here, and then we're going to remeasure. So we're going to rerun it. And then we have our VN as 5.961. So 5.961 volts. And then our V out loaded is going to be 5.638. 5.638 volts that we have. All right. What's next? All right. So the next step, it says use the measurements from step 4 to calculate the quantities below. Show how you calculate and state what you calculated. So all right. Oh, wrong one. All right. So to get the voltage gain, it's going to be V out over V in. So for the first one, we have the unloaded voltage gain. So to calculate that, we're gonna use these values up here for the unloaded. So the V out is 12.452 volts. And we're gonna divide that by the VN, which is the 13.147. Oops. So 13.147 volts. And then we're gonna use the calculator right here. So the 12.452 volts for the V out divided by the 13.147 volts for the V in. And that's gonna give me 0.947 volts for the voltage gain for unloaded. So 0.947 volts. And we're going to do the same thing with the loaded voltage gain, but we're going to use these values right here. So the V out is going to be 5.638 volts. 5. And we're going to divide that by the V in, which is the 5.961 volts. 0.961 volts. And I'm going to do that calculation right here. 5.638 divided by 5.961. And you can see they're pretty close. This one's going to be 0.946 volts. 0.946 volts. All right. And the next step, I think this is the last step, it says use the unloaded and loaded output voltages to calculate the output impedance R out. All right. And so the formula to calculate R out is, it's going to be the load resistor, which is 5.6K multiplied by the V out unloaded, which is the 12.452. And then you're going to divide both of those by the V out loaded, which is a 5.638. And then you're going to subtract all of that by the loaded resistor. All right. Pull that up on the calculator. So, all right. And we type that in right here, the same thing. So 5.6 times the 12.452 divided by the 5.638. And then we're going to subtract all of that by the 5.6K load. And that's going to give us, so let's go on the calculator first. So we have 5.6 times the 12.452 over the 5.638 minus the 5.6K. And then, so we get for R out 6.77 kilo ohms. So 6.77K that we have right there. And I believe that is the last step. All right, and then that's it. And then we still have our circuit. And that one.